Now we have started with design of the foundation. So foundation is lowermost part of the structure which is directly in contact with soil and which can transfer the load of the structure to the soil on which it will be the rest. Now to consider the what are the different functions of this foundation. So first function is to distribute the weight of the structure over large area so as to avoid the overloading of the soil. Second one will be the to load the substructure evenly and thus prevent the unequal settlement. So there are two types of the settlement in the building. One is called as equal settlement, another will be called as the unequal settlement or the differential settlement. In case of the unequal settlement may be due to the failure of the soil below the foundation and which may be leads to the failure of the building. Then third function will be to provide the level surface for the building operation, and the last function is to take the substructure deeply into the ground and increase the stability of the structure against the overturning. So these are the functions of the foundation. Now I have to consider the different types of the foundation. So first one will be the shallow foundation and second will be the deep foundation. The shallow foundations are further classified into spread footing, combined footing, mat or raft foundation. And these deep foundations are classified into pile foundation, pier foundation, well foundation or the caisson. Now we are coming across what is the isolated footing. We are coming across the design of the isolated footing. A isolated footing is nothing but a footing which can be support a single column. That footing is called as the isolated footing, and it is observed that square footing should be economical under the square column or the circular column. Generally under rectangular column, what we are doing, we are providing the rectangular footing. So we have to consider these are the different types of the footings. So this is called as the sloped footing. This is the sloped edge. This is called as the stepped footing. So here we are providing the two steps. So this is called as the stepped footing. And this is the rectangular footing with uniform thickness. So this is the thickness or depth of the footing. Then next one is the combined footing. Combined footing, in that we are coming across the rectangular footing and the trapezoidal footing. The combined footing is to be provided when the distance between two columns is to be less one. In that case we are going for this combined footing, and this rectangular footing will be provided when the load on both columns are to be equal, and this trapezoidal footing is to be provided when the loading on the column will be the different one. Then third will be the mat or the raft foundation. When soil strata is not available or under certain depth, in that case we are going for this mat or raft foundation. So entire one, this one is the mat or the raft foundation, and these are the positions of your columns on the foundations. So this is about the foundation. Then we are coming across the design criteria for the footing. So first criteria that can be used for the footing is the minimum cover. So minimum nominal cover for the footing should not be less than the 50 mm. The actual cover may be the provided for the footing may be greater than the 50 mm. It will be depends upon the chemical composition of the soil, mineral content in the soil, and what is the depth, water table available, and the environmental exposure. Depending upon that one, we are providing the nominal cover, and generally in case of the footing, the cover should not be less than the 50 mm. Again, for the deciding this minimum cover, we have to refer the IS 456 table number 16.a, page number 47 of IS 456 2000 will be gives the idea about the provision of the cover for the foundation. Then second will be the thickness at the edge of the footing should not be less than 150 mm for the footing. So at this point, the thickness at the edge of this footing should not be less than the 150 mm. This is the second criteria for the design of the footing. Then the third criteria will be the bending moment. So the critical section for the bending moment will be considered at the face of the column. Suppose if you are considering this is the column having width equal to b and d is the depth of the column. So the critical bending moment will be the critical at this point at the face of the column. So this is the critical section for the bending moment. Then L is the total length of the footing, B is the width of the footing, B small b will be indicate the width of the column, and D will be indicate the depth of the column. And this distance of your critical section for the bending moment from this point of the footing will be L minus B divided by 2. So this is the distance of your critical section. Then from the bending moment consideration, whatever may be the bending moment we are getting from this critical section, we are calculating the depth of the footing D. Once we are calculating this depth of the footing, now this depth will be checked for the shear. So structure will be safe against the shear. So we have to check this depth for the one. First one is called as the one-way shear, and also we have to check the depth for the two-way shear. So one-way shear, the critical section for the one-way shear will be located at a distance of D from the, that is D is nothing but the depth of the footing from the face of the column. So whatever may be the depth we are getting from the bending moment consideration, and this is the critical section of your shear, one-way shear. So this is your position of the column. Again, the L is the length of the footing, B is the width of the footing, small b will be indicate the width of the column, and this will be indicate depth of the column, and the critical section for the shear will be located at a distance of D from the face of the column. So what is this remaining distance? So this remaining distance will be the total will be the, from the center we are getting this L minus B divided by 2 minus this D. So this is the position of your critical section from the face of the footing in case of the one-way shear. Now we are going across the two-way shear. It is also called as the two-way shear, is also called as the punching shear, and the critical section for the punching shear will be located at a distance of D by 2 from the periphery of the column. So we have to consider the figure where we are getting the position of critical section for the shear. So this figure will be indicates the critical section for the two-way shear. So again, this is the column having width equal to B. Again, L is the width of the length of the footing, B is width of the footing, and this will be the critical section for your two-way shear. So it will be located at a distance of D by 2 from the face of the column, and where D will be nothing but your depth of the footing. Now what is the periphery of this one? So this, from this point to this point, what is the distance? The width will be the B. This is D by 2. This is D by 2 on both side of the footing. So what is we are getting? This distance of the distance will be the B plus D, and similarly we are getting this distance is nothing but, suppose if we are considering the D is the depth of the footing, then from this point to this point, what is this distance? D